Hello, class, and welcome to Module 7. In this module, we will be dealing with CLO 1, 2, and 3. While there are no date restrictions on your modules, focus on completing this before the 8th week of class if you want to stay on a weekly schedule. All right, so let us go through the module overview, objectives, and reading preparation. So, students will learn and understand the water cycling and solids handling processes. Your objectives are to understand the requirements of Title 22, to know what level of treatment is used for different recycled water uses, to understand where solids from wastewater treatment are generated, compare the thickening of water solids. And so we're going to do our reading preparation from the wastewater treatment and disposal 2. You're going to look at chapter 4, which is on water recycling, and chapter 5, which is on the solids handling processes, and also the module 7 math tutorial PowerPoint. And so let's look at that PowerPoint. All right. And so this you'll want to download, and what it's going to do is I'm going to actually bring it up. There we go. What it's going to do is go through all the different math calculations that you'll be doing for this particular module. So let's go through the first one together. So it says a 6-year-old pump motor is to be replaced. The new motor, just like the old one, would run 75% of the time. Both existing and replacement motors would operate at 100 output HP. And that's horsepower. The existing motor efficiency is 86%, while the replacement motor would be guaranteed at 94% efficiency. Electricity currently averages at 0.0780 per kilowatt hour, that's kWh, and we want to calculate the energy cost savings per year to the nearest dollar, assuming that we have a 365 days per year. If the existing pump is replaced with the new pump, neglect any consideration of impact upon demand charges or interest on capital. So let's look at how we break this down. All right. So in this column, this is what we know. So we know that the runtime is 75% of 365 days. We know the output HP is 100 HP. We know the old efficiency is 86%. We know that the new efficiency is 94%. And then we have a couple of equations. The brake HP is equal to the power to motor times times the motor efficiency. And then we can rearrange that to solve for power to motor. So power to motor is the brake HP over the motor efficiency. What we're looking for is the dollar amount that we save per year. So first we want to find out our power to motor. So we're going to take our brake HP, which is 100 HP, and divided by our motor efficiency, which is 94%, we want to change that to a decimal. And so we get 106.38 HP. We also want to do the same thing for our old efficiency. So 100 HP is still our output HP, and our old efficiency is 86%. We're going to change that to a decimal, and we get 0.86. So we get 116.28 HP. We want to set, we want to subtract those two values. So we're going to take what we got for the old efficiency minus what we get for the new efficiency. And so that's our difference, our HP difference. All right. So we're going to start with that. And we are going to convert that through a series of calculations to get to our cost per year. So we start off with our 9.9 HP. We're going to multiply that by 0.746 kW or kilowatts over 1 HP, right? And so that is our equality between HP and kilowatts. And then we're going to take our cost, which is how much per kilowatt hour. So that's 0.0780 over 1 kilowatt hour. Then we're going to take our 365 days in a year, and then we're going to take 24 hours in a day. And then we're going to multiply that by 0.75, which is our 75% for our runtime. And so our HP unit is going to cancel out. The KW unit cancels out. The dollar amount is what we want. Our days are going to cancel out. Our years are what we want. Our hours are going to cancel out. And when we do the math for this, we get 3.785 per year. So that is how much we're saving per year. All right. And that might be 3,000. Let me check that. 9.9 times 0.746 times 0.078 times 365 times 24 times 0.75. Yep, that is 3,000. All right, so this is $3,785 that you save per year. All right, so go through these different calculations and see if you have questions on that. So after your tutorial, there are some videos. These are some videos that will help you understand a little bit more about what we are covering in this particular module. So go through those very helpful videos. And then you have your math assignment, all right? So you want to download this, you're going to complete the math assignment, and then you're going to submit it, all right? And then in Module 7, you have this laboratory that you will be working on. And this is the quality of surface water. This first portion, this is your data sheet. So this is how you're going to set up your lab report. So you're going to have your introduction, you're going to have your materials, you're going to give the step-by-step procedure. You're going to list your observations, and you'll also include any data tables or calculations that you have for this lab. And then in the discussion section, you want to answer these questions. And then you want to make sure that you do have a reference section and that your reference is APA style. If you have questions on how to do your references in APA style, here's a couple of links that will help you understand how to set up your references. And if you have questions, let me know. And then this is the directions for your Module 7 lab. And so you'll go through these step-by-step instructions. This is what your kit should contain. So you should have all of these different tools for this kit. This gives you the breakdown about how much time that it will take. Your key shows you your PPE, your goggles, gloves, and your apron. Here's a video that helps you understand. You want to take pictures of your results, and you will need a stopwatch, or the timer on your phone is perfect. All right, so here's some warning labels to look for. Right here, this will give you a little background about the lab. Okay, a little information about the lab to help you write that introduction for your lab report. And it tells you about the different tests that you're going to do, the total suspended solids, turbidity, the BODs, biochemical oxygen demand, your pH. You're going to look at pH for your solutions. All right, and so here's what's included in your kit. And these are some things that you'll need from your equipment kit. All right, and so you'll need the graduate cylinder, thermometer, test tube rack. You'll need You'll need a plastic pipette and a permanent marker. All right. And then needed supplies, but you don't have them in your kit is aluminum foil, a stopwatch or timer, household bleach, a GPS enabled phone, cooler with ice, which is optional, bucket container for waste disposal in the field, which is also optional, access to a printer, a straight edge, that could be a ruler, and a container that can hold 150 milliliters of water with a secure lid. That's to get your surface water that you'll need for the test. All right. And then your safety, you want to wear your safety goggles, your gloves, and lab apron anytime you're dealing with chemicals, including the test tabs. Natural water samples can contain harmful contaminants and organisms, so wear your gloves and safety goggles during sample collection as well. All right. You want to make sure that you read all instructions for the laboratory activities before beginning. You want to follow the instructions closely and observe established laboratory safety practices, including the use of appropriate PPE. All right. Never conduct field work on your own, especially in remote areas. Always take a responsible partner with you. Okay. So make sure that also you're not eating, drinking, or chewing gum while performing these activities. You want to clean your work area with soap and water after completing the investigation. You want to keep pets and children away from the lab materials and equipment. Okay, and then you're going to go through and select the field sites for the following activities. This kit has enough test material for 10 locations if the sample tubes are washed between samples. All right. So just a note there. All right. And so you want to go through each of your steps. You want to make sure that you do take pictures of your samples. Okay. You do have these figures here will help you do some of the tests. You also have turbidity tests that you'll be doing. And so, very important that you follow the directions. And if you have questions, please let me know. Right? The samples that were tested for coliform bacteria should be treated as potentially hazardous. Be sure to wear your gloves, goggles, and lab apron when disposing of these. Dispose of one vial at a time. Open one vial at approximately 1 milliliter of household bleach with a clean pipette. Immediately recap the vial. Repeat steps 1B and 1C for the other vials. Allow the vials to stand upright for 4 hours. And then you want to dispose of all vials in the trash without opening. Do not reuse the vials after coliform testing. And dispose of other solutions down the drain with water running. Allow the faucet to run a few minutes to dilute the solutions. If tests were performed in the field, dump all solutions into a waste container to be dumped down a drain with the water running when you return home. Throw away all materials from the materials kit in the household trash. And then this shows you how to sanitize your workspace. Make sure you wash your hands thoroughly after performing this activity. And this data table is where you're going to place all of your information. Okay, you have a couple of data tables. These data tables do need to be included in your lab report. All right. All right, and this is where you will submit your lab report. You'll have a quiz for this module. Remember, there are 10 questions. You have 60 minutes to complete the quiz. You only have one attempt, so make sure that you do understand the material before you attempt the quiz, and make sure that you ask me any questions that you have before about the material before attempting the quiz. Right. The last thing is the Module 7 activity. This is on EPA regulations for water reuse. So there's an article that you're going to read, and you are going to respond to the article by giving an essay, right? And in this essay, it should be at least 150 words. And you want to tell what you learned about water reuse, and do you agree or disagree with the type of recycling and why? All right. And so those are the questions that you want to make sure that you answer. You also want to give like an overview about the article, what you've learned from the article. All right. So going back to module 7. So you can see it. All right. So as you can see, those are the assignments for Module 7. If you have questions as you're going through this module, please let me know. Thank you.